All right. Hello, everyone. My name is Alex. Welcome to my talk about MCP, or Model Context Protocol. Now, before we dive into AI and MCP and all that, a few fun facts about me. I've been working in IT, mostly in machine learning, also DevOps, backend, all that, for more than 10 years now. I've been building Zencoder, the AI coding assistant, since day zero. For the last year, I've been mostly doing DevRel work, and this is my event number 39. This also results in quite a lot of flights, and I have 4 cats which are waiting for me back at home on Madeira. Now, MCP is, as I said, Model Context Protocol. Now, before we dive into what it is and what it is used for, who here uses MCP daily? Can I get a show of hands? Okay, a few people. Who here uses AI for work, for coding? Okay, more people. Great. Now, out of those who use MCP, do you use MCP tools or do you use anything else from MCP? Anybody use anything else than MCP tools? Okay, I guess those who use MCP only use MCP tools. Okay, great. Well, MCP has been quite a buzzword for the last year, I guess. But before we dive into what it is and what it is used for, let's make a step back and talk briefly about AI and specifically LLMs. Now, as we all know, when we use LLMs for coding, when we use AI for coding, we really use LLMs. And LLMs are essentially trained to predict the next most probable token, right? The next most probable symbol. And this sometimes can lead to errors. So they are great at detecting patterns, but they are not great at detecting what is actually behind these patterns, right? So they can, like in this case, they detected some specific pattern for the numbers, but unfortunately it is not really grounded in physical world. But well, we all know how AI is with hands, so it's not not surprising. But in general, yeah, that one of the main weaknesses of LLMs is that they lack grounding in the physical world. And what that means is, for example, if you ask ChatGPT to get the response time for Google, it is something that is pretty easy for us, for humans, right? We can do just ping in the terminal, and that's it. I think there's a queue at the entrance. Yeah, but ChatGPT, in this case GPT-5, it can't really do this for us, right? It doesn't have access to ping, it doesn't have access to real-life data. It could maybe pull something from internet, like some average results, but unfortunately this is not really what we want, right? Or if if you use some sort of internal framework, if you use some internal technology, also LLM are usually not aware of those. So if you have some specific company's framework, LLMs would fail to utilize that, right? So they don't have any knowledge about this. They can't access your internal systems, so they can't really get any context from those, and they can help you with that in any way. So essentially, we can technically reformulate this phrase about lack of grounding into LLMs can't collect extra context. Right? So this extra context, again, can be, for example, result of the ping, right? So it's also extra context. It could be some knowledge base from your company. It could be some internal framework, some internal tooling. So essentially, anything that you as developers usually use for context when you are solving the ticket, solving the bug, LLMs usually can't leverage that. They can't leverage that knowledge. They can't access this knowledge. Well, let's give them access to let's allow them to use tools. Let's give them access to databases, to Kubernetes clusters, whatnot. What could go wrong, right? Well, you probably heard about this case when production database was wiped by one of the coding solutions because the developer gave access to production database to LLM, and LLM decided that it is better to start from scratch rather than fixing any issues. But well, jokes aside, there are several ways to give LLM access to tools, and the most common one, the most popular one nowadays, is MCP. And MCP stands for Model Context Protocol, and it was introduced by Anthropic in 2024, like December 2024. And just to give you a perspective on how popular it became in this short period of time, OpenAI, the main rival of Anthropic, actually also adopted MCP. So ChatGPT, like GPT-5 and whatnot, they also can use MCP. Essentially, it has become de facto standard for the industry, for AI, to give access to tools. Now, MCP, the protocol, is based on JSON RPC 2.0, which means that it is essentially just a structured inputs and outputs, and it consists of two main entities. First, you have MCP server over here. MCP server is responsible for two main things. First one, it is advertising its capabilities, right? So essentially, it lists what it can do, it lists what the resources it have, and so on. And then it also is responsible for actually executing those tools, right? So MCP server can be used to access local resources, like a file system, for example. It can be used to access remote resources, for example, Jira or Notion or whatever. And they all are used essentially to get more context to later pass on to LLM. And essentially, anything you can program to get extra information, extra context, you can use as MCP server. And I will show later a few examples on how to use them and how to actually create them from scratch. So that's one entity. And then the other, sort of the counterpart of MCP server, is MCP host. So it could be your ID, it could be Cloud Code, whatever you use. Essentially, it is a proxy for LLM and for you as a user to get access to those servers. So essentially, whenever LLM decides that it needs some extra context, it can ask MCP server to get this extra context. So the overall flow would look like this. So first, whenever we initialize the connection, the MCP client, it could be again ID or Cloud Code, whatever. First, it requests the capabilities from the MCP server. So it's sort of like a handshake between the MCP client and the MCP server. Then, once you ask LLM something that requires extra context, LLM can decide to use one or more of those tools from MCP servers. So in this case, for example, it could decide to use Bash, right? So running Bash commands. And then once it recognizes this need for extra context, it sends request to MCP client. MCP client then asks MCP server to execute that tool. MCP server queries some system. It could be local system, it could be a remote system. Returns the data. It is structured in a nice structured output format. It's passed on to MCP client, and then LLM, based on this extra context, can give you more accurate, more contextualized answers. So again, it could give you answers about your internal knowledge base, for example. But tools is not the only thing. It's not the only feature of MCP. Tools is definitely the most known feature of MCP, but actually MCP protocol defines several more capabilities, which are less known, but they're still worth mentioning. So first of all, first one is resources. So MCP resources is a way for you to serve static context. So it could be files, it could be URL links, or in this case, this is the MCP resource from MySQL MCP. So in this case, they are essentially serving the database schema. It's not really technically static, I guess, but it's a nice way for LLM to get the schema quickly without any special queries or whatnot. So essentially, the MCP client would just use this MCP resource and get the schema whenever LLM thinks it needs to get the schema. But again, the most usual cases for this would be serving files or serving URI, so essentially just static data. Then there is prompts. So MCP prompts are essentially a template of which LLM or you as a user, MCP client, can use to templatize the queries. So in this case, again, this example from MySQL MCP. As you can see, they essentially put in the template sort of like a guideline for LLM on what or how it needs to perform the task, needs to perform the query. And then you just inject the user's request, user task, as part of this prompt over here, as part of this template. And you can essentially create a bunch of prompts right on the fly whenever the user requests some task from MCP server. And in practice, I've seen, for example, one of our clients use this for refactoring. So they define this sort of template where they then inject the name of the class, some rules based on the class, and so on. But overall, the main rules of the refactoring are templatized, and they don't essentially need to repeat it every time when they prompt LLM to refactor some class to a new language. Then there is roots. Roots is essentially defining the boundaries for LLM, so where or what it can access. So in this case, for example, it can access some directory, right? So it can access some URI. And this is essentially the sources of information or extra context for LLM to search for. It is not limited to this, so it is just sort of a guideline for LLM to where to search first. But then, of course, it can decide if maybe this front-end repository is not enough. Maybe it needs to search something else. So it's more of a guideline rather than a strict boundary. Sampling is quite a tricky thing to understand, and it's kind of reversing the dependency here. So if you recall in the schema which I showed initially, the request was initialized from user to LLM to MCP client to MCP server. Now, in case of sampling, this is reversed, and now MCP server can actually request LLM. So essentially, let's say the MCP server needs to refactor something, and it might decide that it wants to ask LLM for some guidance, or maybe for some piece of code. So what sampling allows MCP server to do is essentially create a prompt, create a request to LLM. Then this request will go to the user. The user can approve, the user can modify this request. And once the user approves this request, the MCP server will query the LLM. So it's basically like the inverse direction, right, from the regular MCP tool. And then, based on the response from LLM, the MCP server can then do something else. So again, it could be, as an example I've mentioned, it could be asking for some guidance for refactoring, or maybe it could be, I guess, one of the simplest examples I've seen for sampling, it would be MCP server asking LLM to structure the unstructured data. So let's say the MCP server, as a result of its tool call, got some, I don't know, images or whatever. It can ask LLM to describe that image. So essentially transforming unstructured data into structured data of tags or description or whatnot. And then, of course, last but not least, the most popular thing from MCP is tools. And again, this one is an example from MySQL MCP. So in this case, this tool essentially lists all tables. So let's say you are asking LLM to get some data from your MySQL database. So LLM can first get the list of tables, and then based on this list of tables, it can decide which query it needs to perform, or any other things it needs to do to give you answer to your question. And as I mentioned, MCP tools is probably the most known and the most used feature of MCP. But as I've shown, it's not the only one. Although, to be fair, the rest of them are not really used that much. I think I've seen in practice only people using prompts, and that's pretty much it. I don't think sampling is actually even supported by any client, to be honest. Even Claude Code, I don't think still supports sampling. So essentially, Anthropic introduced it, but they still don't support this in their own products. But this could be maybe it's a rather new feature, so they might finally add support. But then, yeah, tools. Again, as I said, it's the main feature of MCP. And tools, since they're based on JSON RPC, they are essentially just a structured inputs and outputs, right? So here's an example of one tool. This one is from GitHub MCP, which is essentially creating a branch in GitHub repository. And as you can see, it is essentially just defining the description, what inputs the tool or function will take, and that's pretty much it, right? So this text will then be attached to the prompt, which is sent to LLM. And you can imagine if you have a bunch of tools, you would have a lot of those sort of descriptions of the tools being attached to the prompt. So you also need to be careful not to overpopulate your prompt with a bunch of tools. So as an example, I think Atlassian MCP, for example, has around 80 tools. So you can imagine 80 times this would obviously quite inflate the the prompt which will be sent to LLM. But it is what it is. Unfortunately, MCP is still a new technology, and not everybody still knows how to kind of, I guess, cook it properly. But yeah, so there are also a lot of different MCP registries where you can find a lot of different MCP servers. I would say nowadays it is probably thousands of MCP servers already available. As you can see on this example here, it's not just about programming, it's not just about IT. So, well, of course, there is MCP servers, for example, for Grafana, for ClickHouse, for tools which we maybe use and love, or maybe not. But there are also MCP servers for things like, for example, Exa. Exa is a search engine for LLMs, for AI. There is this interesting MCP server, which is essentially querying the Dutch railway system API, and then LLM can essentially ask, when is the next train to Amsterdam, or anything about essentially the Dutch railway. I actually wasn't able to run it on my local machine for some reason, but you can try it still. But closer to heart, closer to development practices, here's some example of MCP servers which you might find useful. So of course, there's, I already mentioned, Grafana. There is Playwright, which we actually will see in action in a second. There is Postgres, to access the Postgres database. Context 7 is quite a useful MCP server, which essentially lets LLM to get up-to-date documentation for a bunch of frameworks. So obviously, LLMs have some knowledge cutoff until after which they don't know anything about the events, about the frameworks. So Context 7 essentially solves this by indexing all the documentation, and then LLM can just query this MCP to get the latest docs for any framework. Then Sentry, of course, you can query your Sentry for logs, for errors, whatnot. And again, this is obviously not the only servers. It's not even probably 1%. It's 1,000% or whatever. And you can find a lot of different examples for a lot of different servers for your tools, which you use every day. And just a good segue to some practical examples. So for the practical examples, first of all, I will use Zencoder as MCP client, kind of, right? And Zencoder is a plugin for IDE, for VS Code or JetBrains. And I have actually two examples. Let me go back to the slides first. So first one is Jira plus Git plus GitHub. So essentially what this allows you to do is, well, from Jira, you can pull the ticket, right? From Git, you can, do all the Git stuff, or LLM can do all the Git stuff. And through GitHub, you can create the pull request, for example. And over here, I pre-ran this yesterday just to save us some time. But essentially, I'm just, in this case, I cheated a bit because we have native integration with Jira. So I can just take the ticket, but you can do the same through MCP. So you can just send the link to the Jira ticket. And through MCP, LLM would be able to query the ticket and get the context. But yeah, here I'm just taking the ticket, asking the LLM to solve it, create a branch, and make a pull request, right? And if you used any AI coding solutions, you're probably familiar with this similar interface, right? So it decided to do some tool calls. So at some point, I think over here, it decided to use Git MCP to check the status, get the branches, and then it used the same Git MCP to create branches on its own, check it out, right? Then it went ahead to solve the ticket, did some code modifications, whatnot, and in the end, as requested, it essentially did again all the Git stuff, which we usually do, right, in the terminal or in the IDE, Git add, Git commit. It pushed the branch, and then it created the pull request through GitHub MCP. And let me show that pull request over here. It's probably, and in this case, because it was my token for GitHub, it is authored by me, and it's probably the most well-written description for the pull request I've ever had. So changes made, all the different modifications, key features, testing. So essentially, all the good stuff which you, as a reviewer, might want to see. There is also a bit of automation on our side where we have code review things, but yeah, that's out of scope of this doc. So that's one example. Another example could be, for example, Playwright, using Playwright for accessing the browser. Playwright can be used for, well, as you probably know, Playwright is, first of all, is a framework for end-to-end testing, right? But the actual Playwright MCP server allows LLM to access browser. It allows to click around on the pages. It allows to fill in the forms on the page and so on. And you can use these to, for example, do the testing, right? So let's say you are developing a website, you develop a web application. You can use Playwright MCP to let LLM navigate to your page, to your web application, and click around, do the testing, and then describe what it's seen in the end-to-end tests. And here's an example of for this over here. Let me open this page. So you might know this page over here, portatechhub.com, right? So it has this drop-down where you can find the conference and you can find the schedule, right? So, and then you can click on one of the pages and see this model for the description. So what we can do through Playwright is essentially, well, here I'm just telling the LLM, now go to the website, navigate to the schedule page, check that talks are correctly opening the model windows with description, and yeah, that's essentially what it is tasked to do. And over here, it did some preliminary work to find existing tests and whatnot, but then it opened the browser in the background, and navigated to the page, found this dropdown, which I just showed, the conference, navigated to the schedule link, and started clicking around. So it just opened the first talk over here, found the model. So as you can see, there is a description. So all worked fine. It went ahead to try another one. I didn't actually, asked it to check my talk, but it decided to test it still. So yeah, again, test another one. Then once it was happy with what it has seen, it closed the browser, and then yeah, it started generating the tests. Then it wanted to run them. I didn't run them, but yeah, basically then it would proceed to essentially run them, check if they're working, and if not, it would fix them and so on. So essentially, if you are developing a web application, Playwright MCP can be quite useful for you for testing, for writing it on tests, and so on. And of course, it's not the only two examples. You can find a lot of different examples and you can find a lot of different MCPs which you might expand the capabilities of LLM specifically for your needs. But then, of course, if you have some sort of internal system, if you have some sort of internal tooling, or maybe you want to create an MCP for your public product, for your public offering, it is also quite easy to develop your own MCP server. And Anthropic provides SDKs in quite a variety of languages, right? So most of the modern languages. I think there is now 10 languages. I don't remember which one they added recently, but essentially, the most popular languages, Java, Python, TypeScript, whatever, you can use them to create your own MCP servers. And it is quite easy to do. So here's an example in Python. So all you need to do, and here I have the function. So this function essentially, as for those who don't know Python, this function essentially is executing a bash command, right? So and then it returns the output of that bash command. So all I need to do to convert this function into MCP server is those three lines, right? So I just import the library, instantiate the server, and mark my function as MCP tool, and that's pretty much it. And then using this code, you can give LLM access to running bash commands. So essentially, it can already extend its capabilities beyond just outputting the prompt, outputting the text for you. But then, if you're familiar with Python, if you're familiar with security, you might already see some issues with this code over here. So essentially, it doesn't do any sanitation, it doesn't do any comment validation, so it's essentially quite a security hole, really, right? So if you just try to run any arbitrary command through this function, it can lead to some vulnerabilities, or maybe just, as you've seen in the previous examples or in the previous screenshot about database, it can lead to LLM doing something harmful, accidentally or not, just deleting something or the database and so on. And yeah, essentially, well, LLM do have a lot of nice things to offer, yeah, right? They also are quite dangerous thing to do, to use. And there are a lot of vulnerabilities which you can find in any MCP server pretty much. Starting from something which is typical to any third-party package, because essentially MCP server is a third-party package which you are executing either locally or on your server. And of course, all the typical, the usual suspects when it comes to executing the third-party code on your machine are the things which you might want to worry about, right? So package name hijacking, executing malicious code, and so on. So essentially, all those things are coming as a sort of additional bonus of using MCP. And of course, you can use the typical tools which you use for any third-party package verification to elevate those things as well. But in MCP, we have sort of another player, right? Another entity in play, which is AI. And AI is still subject to a lot of issues, a lot of security concerns, and so on. And this brings a lot of vectors of attack through MCP. And they all over here can essentially be kind of named as prompt injection, although I do still categorize them in different sort of scenarios. And prompt injection in general is a way for attacker to hijack an LLM. So essentially, for example, you as a user, you're asking about the weather, and then the attacker might inject some extra instructions to the prompt, and then this would make LLM to do something else. So not answer you about the weather, but instead maybe give you some dangerous information or execute the code and so on. I will show some examples in a second. Tool poisoning and tool shadowing is essentially a way to modify MCP servers in such a way that after the tools are injected in the prompt of LLM, they can trigger some malicious behavior. So in case of tool poisoning, for example, let's say your MCP server, you add to MCP server some sort of malicious tool, which once the LLM decides to execute it, will essentially do the remote code execution on your machine or on your server, and potentially give access to your computer. Tool shadowing is kind of similar. So in tool shadowing, you define you name your tool the same as the name of the tool in any MCP server. So let's say I've shown the create branch MCP tool from GitHub. You could create a malicious MCP server which has the tool called the same, and then whenever MCP client tries to call the tool, it would call your malicious tool rather than the original GitHub MCP tool. And then, of course, all of those can lead to malicious code execution, either directly or through the use of AI. And I will actually show in a second how you can do that through prompt injection. So let me switch to my notebook over here. So there is a lot of code, and I will share the QR code for this code in at the end of the talk. But essentially, over here, I have an MCP client, which is based on Sonnet 4. I still didn't update to Sonnet 4.5. It has access to, let me run this. It has access to a few tools. So it has access to local system, local file system. So it can create files, it can write files, can list directories, and so on. It can do fetch, so it can essentially fetch the content of URL pages. And it has access to bash, right? So it actually uses the same bash tool which I've shown in the previous slide. So it can essentially allow LLM to execute any bash commands. And over here, I have 3 pages. Let me open them over here. So I have this page /regular, which looks pretty safe, right? I have another page which is called which looks the same. And I have a third page, which also looks the same, right? Now let's ask our Sonnet 4 to fetch this page and say hi to us. And let's hope that internet works fine. All right. So as you can see, it fetched the content of the page. It was exactly as you've seen. And then it said hi to us. Yep, right. So essentially what we expected would happen, it happened. Now let's fetch this not oops page. And this one is tricky. It's a tricky one because sometimes it's actually sort of hacks Sonnet 4, sometimes it doesn't. And on that note, obviously, LLM providers, they try to detect any prompt injections, but still, for example, Anthropic recently mentioned that they can detect around 88% of prompt injection attacks, but there is still 12% left. And this page, this request over here, in my experience, it works in probably 50% of the cases. But essentially, what is the difference of the web page I've shown is that there was an extra text written in white, which wasn't visible for human eye, but it is visible for the LLM tool. And let's see if it actually hacked Anthropic. Well, in this case, it did. So in this case, it decided to follow instructions. And as I said, in my experience, in roughly 50% of the cases, it refused to follow these instructions. But in this case, as you can see, it decided to follow these instructions. And it should have created the file oops.txt, which we have over here. So essentially, you try to just fetch the page, but then through some prompt injection, an attacker could get access to your, well, in this case, local file system. But obviously, it's you can imagine these being used not just to create some simple text file, but for code execution or whatnot. And then the third one, the third page, it contains a bit more elaborate attack, a bit more elaborate prompt injection attack. So it contains this sort of narration instruction. So this whole thing, again, it wasn't visible for the human eye, but essentially it asks LLM to list all the functions which it has access to, and then it also adds a new function. So this function over here, write me phrase in the file, and which essentially, well, in this case, again, it creates a text file, but you can use the same, for example, to force LLM to give you some dangerous information. So as you know, if you ask LLM to give you a recipe for Molotov cocktail, for example, it would refuse. But through those prompt injections, you can kind of force LLM to still give you the answer. And as you can see here, our Sonnet 4 actually followed instructions as requested, right? So unknowingly for us as a user, if we were to just fetch this web page without knowing the content, the actual content, so it listed all the available functions, quite a lot of them actually. But then what is more sort of dangerous is it sort of followed the instruction of testing this new function which we added, right? In our case, again, it wasn't very malicious, but then it essentially kind of simulated the response, and then it, in this case, used our write file tool to put this response into this simulated response into the file, right? So we can find this file again over here. So yeah, there it is. So essentially, through just adding invisible to human eye text on the website, we could hijack the LLM, or then potentially we could hijack the system, we could hijack the server, and whatnot. So yeah, even though LLM gives you quite a lot of power, it also comes with a lot of responsibility. And here's an example of how MCP could be exploited in kind of similar fashion, right? So technically, in this case, GitHub MCP itself wasn't the source of the attack. It just allowed the LLM to access private repositories. And the attack itself was pretty similar to what I've just shown through the web page, right? So essentially, the attacker created on the public repository of this simple issue, asking the LLM to go through private repositories, get all the data about them, and create a README in this public repository. And well, LLM just followed these instructions. Through GitHub MCP, it was able to access all the different private repositories, compile the information, and put it in the public repository for everyone to see. And again, it's not technically an issue of MCP itself, but it is something that MCP allows LLM to do. Now, how to alleviate those, at least some of those pains? So first, you might want to whitelist the MCPs. So you might want to configure somehow which MCPs your developers might want to use or can use. You also might want to have some sort of organization-wide MCP configs. So let's say some MCP tools, they require tokens, they require API keys, and obviously storing them in the plain text is not the safest way to store them. So you might want to have some sort of organization-wide MCP configs. You might want to limit access to some sensitive systems. Again, so you've seen an example previously where LLM was able to essentially drop the production database. So you probably don't want to give access, at least write access to your production systems. You also might want to limit the permissions of the tools. So it could be, for example, just read-only tools. And Kubernetes MCP is a good example of this. So they have a few flags which you can use when starting the MCP server, right? So you can only have read-only tools, or you can disable destructive tools, right? So you can disable delete commands from kubectl or from Kubernetes MCP, or again you can just have read-only commands. And then when it comes to prompt injection, detection and prevention, it is usually helpful to use some sort of third-party provider. So let's say in the case of fetch, right, so which we've seen before, or web search, there are a lot of different third-party providers which essentially do the web search for AI, and then they either summarize the results somehow or also do some detection of the prompt injections and whatnot. So essentially, they act as a proxy between your MCP server and the third-party system, and they can also add an extra layer of protection to protect your system from prompt injections and any other malicious actions of third-party tools. With that, yeah, that's essentially all I have on the slides. So over here, this QR code, if you want to try the Zencoder for free, you can check this one. If you want to connect with me, feel free to use this QR code over here. And yeah, I will let you scan them, and I will also show the QR code for the repository where you can find all the code with prompt injections. All right, and the code for where you can find all the prompt injections is over here. So if you want to play around, with Hacken Sonnet 4 or Sonnet 4.5, but please don't do anything harmful. But feel free to play around. And with that, I think we have a few minutes for questions if you have any. Yeah.
Anyway,
Mm-hmm.
yeah,
Mm-hmm.
so do that.
Mm-hmm.
Probably see line based. So about you.
Well, first of all, in general, when you run MCP servers, they can be run either locally, right, on your local machine, or they can run remotely on the server. Again, and this server can also be can live in your premise. But technically, your question is not really connected to MCP itself, because your question is about LLM being trained on the code, and doesn't have really technically anything to do with MCP, right? The code would get injected, would get sent to LLM provider, regardless if you use MCP or not, because they are essentially it's the way the LLMs work. And there are different ways to elevate this. First of all, of course, you can host your own LLMs, right? That's one way. If you have a lot of money, if you have a lot of GPUs, that's one option. Most of the LLM providers, like Anthropic or OpenAI, they also have zero-day retention policy, so you can enable that. In case of our product, we also have zero-day retention. If you are security concerned enterprise, we can do that. We also SOC 2 and ISO certified, so we are essentially we are taking security seriously, and yeah, essentially that's, I guess, the main ways for you to alleviate those concerns. But of course, depending on the industry you're working on, there could be some different requirements. So I know, for example, for medical industry, where the HIPAA is involved, HIPAA actually prohibits even not just the personal data being sent to third-party tools, but also the code which works on that on the personal information is prohibited to be sent to third-party tools. And yeah, again, in this case, I guess the only way for you to solve this is to self-host. At least for now, right? Maybe in the future we might get some other ways, but I can't really think of any other possible solutions.
Because there's something interesting when you work with GitHub Copilot or GitLab Duo. So they're not sending the code itself. Like they promise if you have like the license, if you buy the license and not using it as free, they promise not to train on your data. The question is, there's another option like this, no?
Well, they don't train, but they still send it to LLM.
Yeah, but they don't
Right.
train on this.
Yeah, so as I said, there is like 0-day retention policy for most third-party providers like OpenAI or Anthropic, where they essentially, again, in the legal contracts, they define that they don't train on that data, they don't store it, they just use it in transit, basically. So like us, for example, we only use it in transit, we don't store it somewhere, we don't store the pieces of the code which we passed on to LLM. And then once the LLM gives the response, we discard this code. And the same goes for OpenAI or Anthropic or whatnot. Okay. Any other questions? All right. Oh, there is a question. Yeah.
Creation.
Provide also some tools.
Yeah. Yeah, authentication and authorization for MCP is, I guess, painful thing because until recently they didn't have OAuth. In the recent versions of the protocol, they introduced the OAuth. So finally, you can leverage this to to authenticate into tools. Previously, the main authentication method was API keys or tokens or whatnot, especially if you run the MCP service remotely. Now you have OAuth, which to some extent alleviates this pain of tools being not very secure, although still most of the MCP servers do not support this, unfortunately. So you have either to have some sort of proxy in the middle, right, between your MCP client and MCP server, which would authenticate your request. So it could be, Google Cloud's Identityware proxy, for example, or something similar, right? Or you can fork the MCP server and introduce a OAuth on your own. That's also another option. But yeah, unfortunately, security is still a big pain point for MCP in general. Not just about authentication, but in general, as I've shown, there are still a lot of ways to leverage MCP for harmful reasons. All right, I guess no more questions. With that, thank you all for your attention, and yeah.